How are we doing today? I'm Randy with the B-17 project here in Urbana. I'm the project manager. I'm also the inspector, the IA, and we're following the original Boeing blueprints and all of the engineering specifications. And based on the fact the airplane was designed and built in the late 30s and through World War II, it's been somewhat modernized. What we have is, of course, the original Boeing blueprints, but also one of the keynotes is my friends at the FAA. They also have a set of standards. This is the AC 4313. It's basically our Bible as far as modern practices and techniques. So what we're talking about today is rivets. And in doing so, we're going to come to a couple of pages here. This is a description of head markings, which is on the head of the rivet. I'm holding in my hand, this is an E rivet. It's a raised ring. Also, we have an AD rivet. I'm going to show you the difference between the two of them. The AD rivet is a dimple, and this AE rivet, which is a 6 diameter. Both of them are a number 6 rivet. They're both same color, but the difference between the two of them is the material it's made out of, which is denoted by the head markings. So on the AC 4313, due to the fact that the airplane was designed as far back as it was, we go to the engineering drawings. This is an excerpt from the outboard engine nacelle, and it shows one of the longerons and a splice that's built into this longeron. You can see that you have fasteners literally encompassing every mating portion of that longeron. It's a U-channel, and it gives you the side view and then the skin side view. You can see you've got all sorts of chicken scratch hieroglyphics here. So the engineering is calling out what fasteners go into these components. So you find out what your fastener code is. You go back to the drawing notes, and this has been blown up. It's an excerpt from this 4805 drawing, and these are all your fastener codes. So you can see a lot of BAC callouts on these rivets. You've got a 345, a 341. Here's an AN Army Navy call out for a 442, an AN 430. So we want to know what's available today. Well, we're going to go to a BAC spec for that BAC 1345 rivet. What we see is a line down the side of this drawing. It says that this rivet is inactive for design use, and it's going to send you to an AN 456 rivet, and you can see the date that was changed back during the war. So to find out the specs on that rivet, we come over to the AC 4313 table 417 is going to show us that a 456 is a brazier head rivet, quite similar to what this original BAC rivet was, but also the fact that this bottom number means it was superseded by that rivet. So you're looking at that same instant on many of these rivets coming down through here. We've got a 426, which has been superseded to the MS number. This is a 426 rivet. It's an E call out based on the ring. And as you go down through here, you see that a lot of your rivets have been changed, the original call outs. These are a 470 rivet. And that's pretty much what all of these rivets have been replaced to. There's one here in the center. This is an AM 435. Well, this is a Monel rivet. It's not giving you what its head marking is. I've got to go to the next page, and that gets into the Monel rivets. But for the aluminum rivets, all of these rivets have been changed. You're looking at a flathead rivet, a brazier head, and another brazier head. You're also looking at these round head rivets. So the aluminum round head rivet, in whatever head marking it was originally called out in, has been superseded to a 470. So the universal head rivet, excuse me, I got the wrong rivet. So these are all 470s. Now everything's been changed. So when you come back, again, it gets a little Greek from time to time, but you come back to the original fastener callouts, and each one of these codes, it's a fastener code from the drawing. So you can see two different types of codes given out here. You've got a square with legs coming out of it. We come back to what that square with legs coming out of it. It's a skin rivet. Well, it's calling it out as a 1345. And there again, we go to the 1345. It's kicking us to the AN 456, which we go to the spec, and the spec says it's been superseded. The AN 456 has been superseded to the 470. So on the aircraft that we're working on, I'm using two fasteners. I'm using a 426 and a 470. And my authority coming back from the print to the actual spec on that fastener and then to modern practices and techniques allows me to supersede all the original callouts. And by today's standards now, we're putting in just these two rivet styles. There's also differences in materials. They had the lovely job of putting in a rivet that was called an icebox rivet. It was a DD rivet based on what the callout was on the drawing. So you can see that there were several of these rivets that were called out, and it's telling you an AN 442 DD6. Now, I didn't copy it off and bring it out, but there's a PSI rating for each rivet in each spec material that those rivets are made out of, which brings you back to the AC 4313. So that PSI rating for a DD rivet, none of the other rivets meet that other than one, and that is the rivet that has this raised ring, and this is a 7050 rivet. It's an E rivet by head marking, and it has the same PSI rating as what the DD rivet had. That was an icebox rivet. A lot of fun to shoot. You had to heat treat the rivet, quench it, put it on dry ice, and keep it below 40 degrees below zero. And then you had about 15 minutes to put that rivet in. If you didn't, the rivet starts to get really hard and you can't achieve the type of rivet installation that you're looking to achieve. And so when you install these rivets, you're going to put that rivet in this position. You want a diameter and a half in extension protrusion through the part. There's the diameter. And once it's driven, it should be a diameter and a half in diameter on the driven butt and roughly 2/3 of the diameter in height. So go back to what the original call out was and how you install those fasteners, and that's where we're at today. That's how we got that's how we built a B-17 in 2019.